The console surface consists of channel bays. We can have a number of channel bays from a minimum of 2 to a maximum of 6, and the center section. The center section contains assignable controls for our channel processing and our monitoring, together with master faders. The channel tiles consist of a strip primarily concerned with routing and are backed up by a screen that gives you a comprehensive overview of both signal processing status and your bus routing status. The channel strip contains a motorized fader, an attention key for central routing operations and central processing access. We have our broadcast monitor AFL and PFL functions together with overpress PFL. Channel on. Channel on is a dual state indicator. So if the fader is closed, you get a half bright indication on the channel on. When the channel is open, you get full brightness. Above that we have an indicator showing the channel input name, a small meter for showing input levels, a couple of assignable soft keys, and then we move into our dedicated routing section. The routing here is strip-based. Each channel strip contains its own set of routing keys. On every channel you have direct access to your primary routing paths. So right at the top we have the two main program buses in the console, program 1 and program 2. Below that we have a set of 8 keys that default to controlling our mix minus buses, and then 2 shift keys, one to access the second set of mix minus buses 9 to 16, as well as our audio subgroups. Above the routing section are a pair of encoders. These are used to control send levels, input gain, output gain, panning. Their functions are determined by this dedicated set of function select keys. These 16 buttons allow instant access to the aux sends 1 and 2, mix minus buses, our panning, our input gain, our channel output gain and source, as well as what we call quick routes. On the channel screen above the channel tile, we have indicators that show precisely what is assigned to these 2 encoders. The type of indicator varies according to the function. So we have a rotary control for levels. When we get into panning, we have left, right, and when we go to a 5.1 bus, then we use vertical as well as horizontal bars. The 5.1 panning is reinforced by a function that we call touch pan. So from our center section we can call up an on-screen panner that is controlled purely by touching the screen. We can jump to dedicated positions by stabbing just outside the screen. If we want to do locked moves, we can turn on constraints. So I can precisely move from front left to right back, or jump to the center and do a center back to center front pan. And then again I have additional controls on screen as well as on the rotary encoders for divergence and gain, as this is a mono channel. On stereo channels, then I would have additional controls for stereo width, and on a 5.1 channel I can control both the width of the 5.1 source and what we call the depth of the 5.1 source. So it's possible to take an incoming 5.1 source and modify both the front to rear depth and the width of the incoming 5.1 signal. Moving up the display area, above the encoder section is a pictorial representation of the input signal. This is something that we call iconics. It consists of JPEG images that can be loaded via any PC that can access the console via the built-in server. Images are then dropped into a folder and they appear in our Load Iconics menu on the touch screen. To load an image, you select the channel, and then on screen you can page through the various images available and then punch down on the master encoder knob to assign that or use the touchscreen itself. Adjacent to Iconics is a small meter that, if the console is fitted with the Auto Mix option, shows the controlled gain that the Auto Mix is applying to the channel signal. Above Iconics is the bus routing indications. So this is following the routing keys on the channel strip. Program 1, Program 2 are audio subgroups, and then above that is an area that shows the state of the aux sends. If the channel is feeding an aux bus and the level is active, then when you turn on an aux send, it lights up. If the send is down, it shows you that you're assigned to that bus, but the indicator has gone dim to show that the actual send has not been raised. If the send is pre-fader, and the pre-fader, post-fader state can be flipped from the soft key above the channel label, it's shown in green. And then the section above the aux send section is the display of mix minus bus routing. The console has a number of approaches to generating mix minus buses. It can do it additively via 16 dedicated mix minus buses, and it can also do it can generate subtractive n-1s via the channel output. Looking at the additive mix minus system, then we can build mix minuses through the normal method of routing channels to a lot of different buses and then removing channels that we do not want to contribute to those mixes. The downside of that approach is the displays get very busy and it's very difficult to see what is assigned, what is not assigned. So we have a second approach on C10, which is to create a mix minus where all channels are routed to the bus except on the channel that you first created it on. It's the concept of mix minus ownership, and we do this by a push and hold operation on the mix minus bus. So let's say I want to take this channel and assign it to create a mix minus for this channel on mix minus bus 1, push and hold the routing key. It now lights up in red, and that indicates that I have generated a mix minus for this input, which consists of all the other channels on the console minus this input, and I'm using mix minus bus 1. And then if I want to remove a couple of other contributions, instead of becoming routing keys, these become muting keys. And this is indicated by a strike-through indication up in the routing area. So it's very easy to see that I have generated a mix minus for this channel, and these two channels are not contributing to it. When we look at some of the center section facilities, you will see that we have a reverse interrogation that allows us to show all the signals assigned to a bus. To the left of that area is a display of channel processing. It shows you two things. It shows you the channel processing order, and it shows you the state of the processing. Processing itself is controlled from the section just below the encoder select keys. So this area here is an extension of the channel strip. In a sense, up here we've got our function select keys. These define what the two encoders in the channel strip do, and below that we have the actual physical controls for the channel processing. Looking here, we can see that on this channel we have a fader. The fader is green. That's showing that a fader start has been assigned to that fader. So you'll see that if the fader is closed, the fader is still shown in green, but the outline around the fader has gone to show that the fader start is now off. So when you open the fader, it gives you a positive indication the fader start trigger has taken place. And then above that is a display to show that we have an equalizer in circuit. If I take the equalizer out, then that's grayed out. Likewise, we have a compressor. That compressor is pre the equalizer. And then the final two processing blocks are delay, controlled from here, and the insert in-out indication. So this is an insert send and return. It can be sent to any I/O port. There's no restrictions. It can use a digital port, it can use an analog port. The send is always active, so in a sense the insert send is available as another direct output from the channel strip, and it's the return that is switched with the insert in-out switch. Channel processing order is user configurable. Again, this is done from the center section. We attention the channel, and then we go to the bottom row of soft keys on the center section screen. This bottom row of soft keys always relates to channel strip functions. It always shows you the attention channel in the middle, and then you have a series of 6 master menu keys on this side, and any additional keys that are associated with a menu are shown on the right-hand side. If no channel is attentioned, then there is no indication in the display area here, and you will notice that beneath it, in our channel processing section, the displays are blank in the assignable channel section. When I attention the channel, any current settings are displayed here. The in-out status is reflected on the in-out keys to match what is shown on this vertical channel strip overview. And if I want to change processing order, I do that through what's called the channel settings menu. The channel settings menu contains a series of options for the channel strip that are basically set and leave type options. And this is an example of a menu type that we use quite a lot. It consists of columns that we navigate in a left to right function. So the first column is our master headings. It contains settings for auxes and mixed minuses. The second option is for selecting meter source. The main meter on the channel can be assigned to a number of different points in the signal path. It can look at the raw input, pre the channel trim control. It can look at the pre-processing signal, i.e. after the trim but before the effects of any EQ and dynamics. It can look at the pre-fader, so you can see the effect of EQ changes, and you can also have a confidence monitoring for the channel output. If you are feeding a recorder, or if you're using the subtractive n-1 system, you can see the levels on the channel output. The label on the left-hand side is showing you what you're metering. So if I change the meter source, again using the scroller, to, for example, pre-processing, that shows you that you've reassigned the main channel meter to pre-process. However, you always retain input metering on the channel label display. So regardless of what you have on the main channel meter, you can always see down here what is the input signal to the channel strip. The next entry is processing order. Now we see the various options, and we can go to the next column, and we do that using these left-right keys. This takes us through any displayed columns, and the active column is indicated on the touchscreen. And then again, we can scroll down and pick up, for example, the delay block, and we push down on the encoder, and then we basically take that delay block, and then to move its position, I punch down on the encoder, at which point the delay block will change positions in the channel strip display. So now we've moved the delay to just before the fader, so the delay is at the end of the processing chain. We even have the flexibility to take the dynamics processing, for example, and put it post-fader. Or again, we can take the insert point post-fader. And as the insert send is always active, this gives you an assignable pick-off point for feeding backup recorders in sort of complex broadcasts where you're doing live backup. Again, we use the same menu for formatting the channel strips. We either pre-format fader strips with mono, stereo or 5.1 formats, or if we have an unformatted fader strip, the act of routing a signal into the fader strip automatically creates a formatted channel. Our I/O can in turn be formatted. So you can deal with mono, stereo and 5.1 sources, and they can all be routed as a single source, regardless of the fact that they are actually multiple sources. So just to demonstrate the format operation, if I take channel 9, it's currently mono. If I want to make it a stereo channel, then again I outline stereo, use the encoder switch to select it, and because this effectively would overwrite a signal currently assigned to this channel, you have to confirm this operation. And now that channel has been reconfigured in stereo. And the channel format is displayed right at the top of the meter. Just to finish off this menu, then we have fader starts. We'd have a list of any GPIs assigned to fader starts. When the function select keys are off, then the two encoders become free controls, as do the two switches above the channel strip display. We can assign any variable channel parameter to these encoders so that we always have access to a pair of parameters without having to use the function select keys. The first thing we do is attention the channel that we want to assign a free control on, bring up the parameter menu, select free, just turn the encoder and a question mark appears in the encoder label, and I'm going to assign it to input gain. When I release the function select key, and if I turned off free, you'll then see that gain has been assigned to the upper encoder. So the function select keys always override free controls. When you release the function select keys, you return to whatever free control that you have programmed. For example, let's assign compressor threshold to the lower control. Attention the channel, parameter, the free menu, attention the encoder, and then select threshold. And instantly you see the little 4-character label for the threshold control appear underneath. And when I release the free control assignment process, we then have threshold for the compressor. Free controls can be made part of presets, so that when you load a preset, it automatically configures free controls. And free controls can be contained within a control link, so that when you assign a source into a channel strip, the free controls are automatically programmed for you. Channel processing, in terms of EQ and compression, is controlled from a dedicated set of encoders in the center section. Channel processing itself consists of a 4-band equalizer and a compressor, together with the insert and delay functions. The equalizer itself defaults to being a 4-band parametric equalizer with 2 shelving bands and 2 parametric bands, but we can optionally reconfigure the bands to be filters or notches, as well as shelving and parametric bands. First of all, when we attention the channel, we see the labels appear in the equalizer section and in the compressor section. If we want a graphical overview of processing, we select parameter and then we select show. And this displays us EQ and dynamics transfer graphs, as well as a much larger version of the channel processing indicators that we see next to the mixed minuses on the channel screen. If I place an equalizer in circuit, then initially it's shown with a flat green line to show that the equalizer is flat. And we have a shelving EQ, parametric 1, parametric 2, and another shelving EQ. The shelving bands have 2 encoders. The parametric bands have 3. For the shelving bands, we have gain. The second encoder is either frequency or it can be slope. And this applies both to the parametric option and a shelf option. So you can vary the slope of a shelving EQ the same way as you can vary the Q of a parametric band. So you can have a very steep slope or a gentle parametric slope. At any time you can zero the EQ by push and holding the in key. So just looking at a single band of shelving EQ, that's showing us how you go from a standard sort of gentle shelf to a more pronounced shelf with a small amount of overshoot and undershoot on the curve. With the mode switch, we can, instead of using a shelf, we can use a parametric. So we can change this into 4 fully parametric bands of EQ, again with variable slope, variable frequency, variable boost and cut, or we can take it one stage further, and now instead of a shelf we have a filter, and that filter can be 12 dBs, 18 or 24 dBs per an octave, and that's indicated by no indication for 12, half bright for 18 and fully bright for 24 dBs per an octave. For the 2 mid bands you can select a a notch filter, which is a very sharp infinite notch response. And again, you can, if you're using the filter for the first band, then you can configure the second band to be a shelf. So that gives you a shelf on the second band. So now you have a filter plus a 3-band parametric EQ. The compressor has variable ratio. It has attack and release, variable attack, push down, variable release, and variable threshold and variable makeup gain. The in-out state again is indicated just the same way as it is on the channel strip. Next to the dynamics is the insert in-out key. The insert, a 4-character insert label would be shown underneath if a device had been assigned. And then finally we have the delay section. The console has 64 channels of assignable delay, and delay can be used in the channels or in the audio subgroups. The maximum value for this delay is 5.4 seconds, and delay is placed in circuit with the delay in-out key. According to how you want to use the delay, you can cycle through on the delay time knob the units that the delay time is displayed in. So you can look at seconds, you can look at milliseconds, you can look at frames, or you can look at samples. Delay in-out status is displayed again in the channel strip process overview on the left of the mix minus buses. As well as a comprehensive snapshot system for resetting the whole console, we have a subset of that which are individual channel presets. These can be used in a number of different ways. They can be used to bring back different formats of EQ and dynamic settings, or they can be used to bring back complete settings of a channel strip. One way that this could possibly work is with, again, the less experienced user has come in to do a midday news show or an afternoon news show, and every day they have different presenters for these shows. For the novice user, he can come in, he can be told, he can pick the script up, he sees the name of the newsreader, he can then load preset in this preset list, as well as settings for things like stereo channel, aux off, 4-band default EQ. We see a setting for Steve, which is the name of the presenter. Again, he can go down, he can select the setting, he attentions the channel strip, and then when he pushes down on the encoder knob to transfer the preset to the channel, all the routing, all the signal flow, all the signal processing, including the iconics picture, is automatically assigned to that strip. Presets are like a snapshot, except they apply to a single channel as opposed to the whole console. And when you make a preset, you determine how much or how little of the channel is reset by the preset. So if we were to look at the other end of the preset system, which is how we create presets, we do this via the main console menu in the MISC page, presets. And then we get a list of our existing presets, the option to make a new preset, and when we have a selected preset on the right-hand side, then we see a list of all the various channel elements that can, or have, well, in this case have been included, but can be included in a preset. So for example, if I looked at a parametric EQ preset, then in this preset the only thing saved are the EQ settings. None of the rest of the channel strip functions are included in this preset. So as you can see, the preset concept is very easy operationally for the novice user. In fact, the console takes that one stage further by actually linking the preset to the console source routing, in which case, purely by the action of routing a signal into the strip, that action will fire the preset automatically. The user doesn't even have to go to the preset menu to do this. Just to show you how this functions, we use what we call quick routes. This is another use for the encoders. It's the last button on the right-hand side, and it's called RTE for route. And now these two encoders become selectors for a predefined list of signals. Two encoders, one is for the channel input and the lower one is for the insert, send and return. So if you were to use a lot of outboard signal processing, it can be automatically assigned through the quick route system. However, the top list is the one that we're going to use for source routing. As I turn the encoder, I see the names of various sources displayed in the list. The current source is always shown in blue. To select a new source, for example, I'm going to just select silence, and you will see that when I selected silence, the channel strip was actually cleared by the action of selecting silence. So I've associated a channel preset that actually deroutes everything, that is a sort of restore, a zero the channel preset. If I then now go and select Steve Mic, which is the input for the microphone that the presenter is using, taking that input source reconfigures the channel strip in a single action, making it very easy to, again, for the novice user, you can include routing within the preset, so that assigning a channel to an input automatically assigns a channel output to a return path. We've been through the channel strip in detail, but in reality, the strip is very fast and very intuitive to operate. Very simply, the channel fader, the channel on, route to one of our program buses, configure a mix minus, change channel gain through the function select system, aux sends, mix minus levels, panning. Very, very fast and very, very visual. All the time, the display gives you a complete overview of what you've set up on the channel strip. Your primary controls are not assignable. They are there on a strip-by-strip basis. If you need to route 5 channels to program at the same time, it's just 5 button pushes. Deroute them, it's the same deal. If you quickly need to knock someone out of a mix minus feed, it's button push away. You do not have to go through a central assignment panel to do any routing on the C10. It makes this very fast. EQ and dynamics, again, through the assignable center section. Everything is very, very close. The front to back depth of this surface is very, very small. There is nothing that you can't reach. In a configuration like this, we've got 32 channel strip faders and we've got 8 assignable center section faders. So that's 40 faders in the width of your arms.